at the Catholic University of Leuven, also in Belgium. He has worked there on industrial biotechnology. He has held lectures on microbiology and bioprocessing. And now he is working as innovation manager in Ghent in the Biobased Valley, and he is coordinating a Horizon 2020 project called SuperBio, which provides innovation support to SME and is there to set up new value chains in the bioeconomy. Welcome, Stefan. Before he will start his presentation, some technical instructions. We have all participants have the possibility to ask questions in a written procedure, either to the question box or to the chat box. I would prefer to the chat box because it's more readable. We will answer to the questions at the end of the seminar. You can also request the slides by mailing to us, or at the end it will be uploaded, or the whole presentation will be uploaded to YouTube and will be retrievable from the CommBeBiz website. So far the technical instructions. Now let me start with 7 things you should know on technology readiness level, TRL. So next slide, please. The technology readiness levels are there to identify ascending maturity stages of technology developments. TRL are a management tool to assess the further input to proceed. TRL are conceived by NASA on a 9-step scale: concepts, pilots, prototypes. TRL range from proof of principle, step 1, to industrial validated products or developments, step 9. TRL are asked when applying to a H2020 technological project. TRL vary from industry to industry, so machinery differ from IT considerably, and TRL are most different in the bioeconomy, dealing with nature. And this is the topic of Stefan. Stefan Ruyters, over to you. Start your presentation, please.
Thank you, Sylvia. So welcome all. I will first introduce our organization a bit. So we are Flanders Biobased Valley, a cluster organization in the port of Ghent, Belgium. And we are supporting the development of the bio-based economy and innovation in the bio-based economy. You can go on to the next slide, please. So Flanders Biobased Valley is a non-profit organization, and it's a cluster of companies who are producing biofuels in the port of Ghent. So it includes biodiesel and bioethanol production from first-generation feedstock. So in this area, 90% of the Flemish quotum for biofuel production is at this site. So it's an important biorefinery cluster for biofuels in Flanders. Next to that, in the port of Ghent, we have established Biobase Europe pilot plant, which is a pilot facility where companies can upscale their processes and is indeed aiming to increase the TRL level of technologies in the field of the bio-based economy, and more specifically in industrial biotechnology. Next slide. So this is just an overview of the members within our organization. Next slide, please. So when we are talking about technology readiness level in the bio-based economy, the example which is the easiest to explain is based on industrial biotechnology, which is regarded as a key enabling technology by the European Commission. So industrial biotechnology is about fermentation, so it's about producing products from sugar feedstock, mainly sugar feedstocks, by using microorganisms. So we all know, of course, beer production, which is industrial biotechnology. So it is more or less the same as producing beer, but then using other microorganisms that can produce a variety of products, chemical products, including ethanol, so biofuel, but also lactic acid, succinic acid, and many others, also more bulk chemicals, but also more specialty chemicals. So it's the easiest example to explain the technology readiness level and what this implies in the bio-based economy. So here you see the overview of the TRL levels as defined, and I will go over these starting from TRL 3 and 4. So 1 and 2 are more fundamental science where you can have a concept formulated, but then you start at technology readiness level 3 and 4 with an experimental proof of concept. In the end, when you are developing a technology, so when you are developing a microorganism which can be genetically modified, the aim is in the end to produce a compound more efficiently, more sustainably than it is currently done. For instance, compared to chemical processing. And the aim is hopefully then in the end that it will be more cost effectively than what's performed today. So when you are developing your technology, you should have these issues in mind. So this should be your aim to produce more efficiently or more sustainable process. So TRL 3 is about experimental proof of concept, so that's really lab work. So you can move on to the next slide, please. Yeah, so it's really testing your microorganism. So I will focus on the microorganism in a fermentation. So that's the first technology that needs to be developed, let's say. And there are different ways to do so. So you can improve your process by tweaking the microorganism, as I already mentioned, by, for instance, genetically modifying your microorganism or by adapting a microorganism. Otherwise, it's also possible to focus on fermentation conditions and the fermentation medium and improve your process. And in the end, the yield and the productivity are the main issues to improve at this stage. So you want as much of your product produced by a microorganism as would be possible based on your feedstock. It's mostly done in standardized and defined conditions at very small scale, and trying to increase the process or improve the process and to increase the knowledge on your process. And I would say it's already important to take commercial aspects already in consideration at this stage. So this implies the cost that can be that relates to the selling price, so that you have an idea of the costs already at this stage to know whether it's a good process which if you compare it to currently existing processes has potential. So that's already important to take into account at this TRL level. Next slide. So that's for 3 and 4. As I mentioned, I work in close relationship with Biobase Europe pilot plant here. They are focusing on higher TRL levels, so that's TRL 5, 6, and 7 in some cases. So that's why I also will focus on these stages. So if we move to TRL 5, TRL 5 states technology validated in a relevant environment, and TRL 6 states that technology is demonstrated in a relevant environment. These two TRL levels are closely coupled, I would say, and depends a bit on what you define as validation and what you define as demonstration. Next slide, please. So TRL 5, it's important to know when you are dealing with the fermentation process in industrial biotechnology. Fermentation is only one step in the integrated process. So that's important. So there are also other processes which at this stage are important, and then I'm talking about, for instance, filtration, centrifugation, drying as well, formulating your product. So fermentation is only one step, and then the remaining steps are also important at TRL 5. So what's done then at TRL 5 is translating your technology and your parameters that you have defined in the lab, is translating that to industrial relevant equipment. And that's what we do here at the pilot plant. So we have equipment, state-of-the-art equipment, which is used in industry to test certain processes. So it's about selecting the type of the equipment. Like there are different types of centrifugation equipment, different types of filtration possibilities. So that's done here. The scale is also important. At which scale do you want to operate? Will you be producing a bulk chemical in the end, or are you so at a high volume level, or are you producing a specialty chemical at very low volumes a year? So that's also important to take into account at this stage. And there might be pumping and flow issues involved that relates, for instance, to the viscosity of your medium. When you have a slurry which is high viscosity, there can be problems in pumping, but there can also be problems in establishing the flow from one equipment to another equipment. So industrially relevant, that relates mainly at this stage, at the piloting stage, scale and volume, so that they are important. And a higher TRL level is not always related to the volume that you are working on. So that the volume depends on the application and the market of your product, and is not related to TRL level. So at this piloting stage, you aim to validate the technical viability, but also already at this stage is the economic viability. So at this stage, TRL 5, you also take into account this techno-economic analysis. So that's important. So that's the first step, is this translation. Another important issue during piloting is the fermentation medium after the fermentation. So as when you're dealing with industrial biotechnologies, with microorganisms, they produce your product, but they also produce a lot of other components. So it's a highly complex and integrated network of different pathways, which you want to focus on a certain compound, so a certain product, but there will always be other products made as well. So, and these products you want to get rid of. If you want to have a pure product, you want to get rid of the co-products. And also of unfermentable sugars. So within your feedstock, you can use a defined feedstock, but there are when we're dealing with a bio-based economy, and I will go into detail later on with waste feedstocks, that might be an issue. And then downstream processing, as already mentioned, you want to get rid of the water. Actually, when you're dealing with fermentation, you have about maybe 10% of the product when we talk about good yields already. So it means that more than 90% of your medium is water, from which you want to get rid of. So concentration is an important step here, and can be done with filtration, centrifugation, but also evaporation, for example, and extraction. And it's also important to take into account what the purity that is needed for your application and for your market. So that also relates to your product, but also relates to the market that you are in. If you are in a pharma related market, this would be purity is most of the times very high requested purity, while in bulk chemicals like ethanol or other, the purity might be less important and less strict. And downstream processing can, if you talk about cost, it can be about 50% of the cost. But if you want to go for really pure products, it can go up to 90% of the cost of the whole process, which is related to downstream processing. So this also shows the importance is about the technology readiness level is on the fermentation step and the microorganism, but the downstream processing is in terms of commercial, from a commercial point of view or an economic point of view, very important. So at this stage, you will be you are validating your technology. So you will be analyzing the yield and the productivity of your process. So how much product that you are getting, and how much product in terms of feedstock that you supply that is produced. So that's an important parameter. Also information on energy usage and information on waste generation. So the first step, TRL 5, is about validation of this technology. So we will be gathering data to show that your technology works on a larger scale, and that also involves, as I already said, the scaling, but also involves, for instance, pressure issues and gas transfer issues. So we'll get this information from the piloting scale. The next step, TRL 6, it also relates a bit to TRL 7. It's about the demonstration. So demonstration means that you are producing a certain amount of your product at a certain quantity, and you will be using, of course, the data that you have developed at TRL 5. And this enables you to produce reasonable quantities. You will enable to have your product in your hand that you will be able to test the activity of, but also to enable to test this in different applications and markets and so on. So that's the demonstration scale. But also important at TRL 6 is that you are running an integrated process. As I already mentioned, you have the fermentation, but you have to run the integrated process from the feedstock. If there would be pre-treatment involved of feedstock, then also next to the fermentation, go to the downstream processing and the formulation, so really having your product in a final composition. And this integrated process, so at the demonstration scale, can be divided into different parts. So in different places, for instance, or at different times as well, if that would be the case. So that's about demonstration. So these are actually what I mentioning here. The key aspects of a relevant environment is about productivity and energy. The next slide, please. So I mentioned TRL 5, 6 is about the demonstration, as I already mentioned, and then we move on to TRL 7, but I also relate that to TRL 6. So 7 is about the operational environment, and when you are at TRL 6, it's less about the R&D. It's less about technology development, but from TRL 6 forward, it's more driven by management confidence, for example, and by showing to the management, but also to investors, for instance, that your technology is promising and that your technology is mature, that you have solved issues, that you have a certain productivity and a certain techno-economics. So from TRL 6, it's less about the technology, it's less about R&D, but it's more about confidence and about commercial and economic issues, actually. Next slide, please. So as mentioned, it's about the economy of the process. So that relates to your product. It relates to the product, but mainly to the application in the market. So what's your product worth on that market? So about selling price. As you know, price is very insure actually, so it can change at any time. It can change in the future, which makes your process maybe in the future economically viable, but not now. So these are issues that you encounter. At TRL 6, it's important to use a feedstock that you will use on a commercial scale. So, for instance, when we're dealing with upscaling fermentation, you can choose liquid dextrose, which is less pure than crystallized dextrose or sugars. Or you can use waste feedstock, which is even more undefined than a sugar feedstock, or a purely sugar feedstock from first generation biomass. It's about industrially relevant scale and volume, so you need to increase your scale and volumes to what closer to your industrial scale, and there you have issues of pressure and gas transfer. So at the bottom of your reactor, you have a higher pressure, which your organism should stand, but also gas transfer is affected by the pressure, by higher pressure. So you can have limited or decreased gas transfer at a larger volume. So that's important, and that, of course, can have an impact on the yield that you get. So TRL 6 is about getting this information. When you're getting, well, TRL 6, when you want to get to TRL 7, that's an important issue. The fermentation medium, so this most of the time it's 4 and 5. This is less important, but from 6 onwards, you want to have a fermentation medium, which only contains what you actually need within the fermentation. So cofactors, trace elements, vitamins. These are expensive, rather expensive ingredients, and you want to limit their use. So that's at this stage also important. And also, you will need piloting to generate the data that you need at this stage. So it means that you define at this stage, this will be my commercial process that I want to run, and you will have to do piloting to get the data that you need. It's about fluxes within your system and pumping. It's about temperatures, and it's about concentration of the product. Then what makes different with and it's about also, well, maybe I can tell that here in the operational environment. So that's TRL 7 then. What are key factors in the operational environment? And that's what you want to test at TRL 7. You have to do it in one place actually, so it should be the fully integrated production process. And you can only simulate that in one place with real equipment, for instance, in a pilot facility. It's also about recycling water and heat. So you should take into account that whether you can reuse the water that you are using in order to decrease the cost. But it's also about side streams that you're generating, product streams, byproducts, but also when you're doing downstream processing. You might generate solvents, which you can reuse, for instance, and you might be generating waste, for instance, your microorganism that you have produced. You might be producing a certain amount of waste here, which you want to valorize or which you want to get rid of at a certain instance. So this running at TRL 6 and then 7 to reach to TRL 7. You want to get information on these kind of things. You also want to run a longer time to show that your process is robust. But also during this longer time you can have more information on the recycling issues, but also on building up contaminants. So it might be that when you are running a longer time that you can have contaminants which are building up due to recycling, for instance, water or other solvents or so. So therefore it's important to run in this operational environment for a longer time the scale would be 10 times the scale that you have used during the piloting stage, and running would be for 500 to 1,000 hours. This would mean that you are getting at an operational environment and that you have established this TRL 7. Next slide, please. So I'm not talking here about TRL 8 and 9. Those are more related to the prototype, but really to the commercialization, which are more specifically issues. So I'm not talking about these issues. I'm more involved into the innovation. And when we're talking about innovation in bioeconomy, it's about fermentation, as I already mentioned, as one case. You can use a microorganism, you can use a genetically modified microorganism, and in that case technology is the microorganism, as I already explained. But innovation in the bio-based economy is not only about microorganisms, so innovation can be on many other topics as well. So it can be about using waste feedstock to replace your current sugar feedstock, for instance. So, for instance, if we're talking about bioethanol production, currently done from wheat, for instance, or corn, these are, let's say, easy to handle feedstocks, while now we are more looking into second-generation feedstock, which are byproducts, agro residues, for instance, and these include corn stover or wheat straw. Wheat straw currently used, for instance, to produce bioethanol in Germany, but also in the United States. So it's about using waste feedstock, and then you might get back to your microorganism, because this feedstock is an undefined feedstock, can contain different contaminants and also different sugars. So there can be toxicity involved, and you might have to adapt your microorganism to this feedstock. So that means that you are falling back to a TRL 3 that you have to work on with this feedstock. There might also be innovation involved in processing and purification of the feedstock. So that does not relate to the microorganism, but to the feedstock, and you have to define a technology to do so. But innovation can also be in other fields. So you can also, it's not only technology based in the bio-based economy, but can also be in other fields such as collection of your biomass, storage and storage conditions of the biomass. So that's also important. And it gets really important when you're getting into a higher TRL level. It's important that you can collect the amount that you need to have a commercially viable process. So that adds complexity to the TRL level. So TRL of your technology, fermentation-wise or processing-wise, can be TRL 6, 7, but it's also about your feedstock and getting your feedstock there, the innovation, or at least the commercial feasibility is also about that. So that adds an extra layer to this TRL in the bio-based economy. And the TRL level is also, let's say, in the project I'm running now, this was also, we also had a case about extraction of compounds from a waste stream from food. And also there, well, the technology itself is at a high TRL in the sense that these technologies are state-of-the-art technologies which are currently used in industry, but they haven't been used on this feedstock. So it's about established technologies, but the innovation here is not about the technology, but also about applying these technologies, applying these equipments to this kind of feedstock. So that's also a bit complicated in terms of TRL level. So TRL is on technology, and you would expect a high TRL level, but in the end you're producing or you're using a waste feedstock which can pose some problems on your process when you're running a longer time. It can be that you can have the process of TRL, that it goes faster than when you are developing, for instance, a microorganism. So TRL is not about time that you are in a certain phase. That's really about the technology development. And when we are talking about more than one technology which is involved in a certain process, integrated process, then the lowest TRL technology defines the overall TRL. So that's regarded in that sense. And as you might know, when we are talking about innovation and innovation funding from European Commission, so SME instrument, it starts from TRL 6, and that means that when more than one technology is involved, that the lowest technology should be at TRL 6 already. So that's a rather high TRL rating. Well, next slide. Okay, I was expecting another slide, but no problem. So that was indeed the end of my presentation. I just want to mention the project that I'm working on currently. So it's a SuperBio project. It's a Horizon 2020 project, which is about innovation and which is about supporting SMEs in the bio-based economy. So we want to support them and provide them with professional innovation services. And next to that, we are building value chains, new value chains in the bio-based economy. Thank you very much.
Thank you very much, Stefan, for this great presentation. I have learned a lot as well. So TRL in the bioeconomy is actually a multi-layer issue, I understood. And I see no questions on the screen. So I have one question to you, Stefan. It's also concerning this very hot topic on second generation feedstock, the waste feedstock. Is it actually ready for market, or would you say it's still in the pilot phase, TRL level 3 to 4? What's the overall state of the art with this new technology?
Yeah, you mean with waste? Well, there are lots of things in TRL 3 and 4, I would say, but there are things which are really at the demonstration scale. So when I talk about bioethanol production from wheat straw, that's done at commercial scale even, or at least at demonstration scale. There are also some technologies, for instance, a sugar beet pulp, which are on let's say TRLs 5, 6, let's say at that stage. So they are developing technologies at that stage already. But a lot of these things, and because of the complexity of the feedstock, but also of the processing, and then also commercial aspects, which are in these days not very good for bio-based economy, and regarding the oil price, for instance, then yeah, that comes into play as well, and that let's say holds developments to a certain stage.
Mm-hmm. And does this scale of TRL really help in the bioeconomy to assess maturity stages and maybe also to attract investor? Is this a concept that helps in the biotechnology, the TRL?
Well, as mentioned, I think it helps a bit. So it's a certain point, but it's really about technology. And I would say in bio-based economy, it's not only about technology, it's also about the feedstock, for instance. So it's different compared to other key enabling technologies. So I would say that it's a part of the story, but there are also, when you're talking about commercial viability, there are also other important issues such as the feedstock, mainly maybe the feedstock. So that's as mentioned, it adds some extra layers to this when you want to really invest in this technology and really commercialize it, it's not only about TRL, but it's more than this only.
Mm-hmm. Mm-hmm. Okay.
And might be different compared to, for instance, ICT or maybe nanotechnologies. When you have your technology, the commercialization is maybe easier. Once you are at a higher TRL level, commercialization might be easier compared to bio-based economy.
Why is this precisely so?
Because of extra layers of complexity in terms of feedstock collection, price of feedstock. Waste is cheap now, but the price can increase in the future as well. If waste is not waste anymore, but resource, price can go up as well. So.
Mm-hmm. Mm-hmm. Dependent on market conditions. There is one question, if I may. Pedro Reino from Portugal asks, is there any biorefining commercial technology or process running in Europe? So are the biorefineries already commercial?
Yeah, there are a few. So I know that Clariant in Germany is producing bioethanol from wheat straw. In Italy, you have Novamont, who is producing monomers for bioplastic production. I think BioOn in Italy is also having a demonstration facility, and there is another one as well in Crescentino, Italy. Can't remember exactly what they are doing, but they are also having a biorefinery over there. And of course, yeah, you have many biorefineries based for bioethanol and biodiesel production, of course. Mm-hmm. First generation.
Yeah. Also, question to the engineer from the Bioeconomy Valley in Ghent. I know you have a bio-based pilot plant. What is it for the projects there? Is it to help them scale up, or what's the main activity you're doing there at the pilot plant?
Yeah, it's about scaling up indeed. So scaling up fermentation, it can go from 100 liters up to 15,000 liters. So that's already a lot. And it's about translating your technology into industrially relevant equipment. So also it's fermentation, but it's also downstream processing. So translating what you have done in the lab, where you might have used Buckner funnel to filter off something. We will translate that to, for instance, a filter press or a rotary vacuum drum filter or things like that. So it's about translating your technology, and there's also another possibility is adapting your technology. So if you have a current process, let's say, is adapting your process maybe by using new equipment, which would be better with a better yield or better purity or things like that.
Okay, so you will see, everybody sees where you can reach Stefan here on the last slide. There's his phone number. I miss in the moment his mail address, but you can mail to me and get his mail address and also the presentation Stefan just held. So if there are no more questions from the audience, I think we have to thank Stefan for this very good presentation, and I have to thank the attendees for the participation to this webinar. We will have next week also we will have a testinar. It's a testing webinar where 3 projects are presenting to an evaluator and get during our session a feedback on their potential project-wise or market-wise. So stay tuned and goodbye.
See you, bye.
Bye.